All right, page number 6, we are back to a no calculator problem. Again, we have a graph of f, and we're looking at an area function, g of x. So the graph of the function shown above consists of two line segments. G is the area between 0 and x. All right, so part A. Find g of 1, negative 1, find g prime of negative 1, and g double prime of negative 1. Start with g of 1, g of negative 1. Set it up first. That's the integral from 0 to negative 1 of f of t dt. Now, that's not right? That's backwards. We need the lower number to be the lower limit of integration. So change this so that it's negative integral from negative 1 to 0. All right, so negative. What is the area between negative 1 and 0? So here's negative 1, here's 0. It's just this triangle here. So that's 1/2 times a base of 1 and a height of 3. So it's a positive area, but remember, we have a negative out in front of our integral. So this is negative 3 over 2. So g of negative 1 is equal to negative 3 over 2. Now, when you calculate the other two, the derivatives, you need to make sure that you have a relationship on what g prime of negative 1 is equal to in terms of f. So g prime of negative 1 is equal to f of negative 1, because when you take the derivative of the integral, you're going to cancel out and get the x down there. Okay, so what is f of negative 1? Take a look at the graph. F of negative 1 is 0. So g prime of negative 1 is equal to 0. For the next part, do g double prime of negative 1. And again, you have to show what that's equal to. That's equal to f prime of negative 1. Now, f prime of negative 1 is the slope at negative 1. So what is the slope of the graph here? So we're going rise of 3, run of 1. So slope looks like 3 to me. So g prime of negative 1 is equal to 3. So did we answer the first question fully? Find all those values? Check. Okay. And then part B. For what values of x on the open interval negative 2 to 2 is g increasing? Explain. So I'm going to start here. G is increasing when g prime of x, which is equal to what? F of x, is greater than 0. Something's increasing when its derivative is positive. That's all we're saying. All right, so where is f of x greater than 0? F of x is greater than 0 between negative 1 and 1. All right, for part C, for what values of x on the open interval negative 2 to 2 is the graph of g concave down? Explain your reasoning. G is concave down when g double prime of x, which is equal to f prime of x, is negative, less than 0. F prime of x is less than 0 when f is decreasing. You don't have to write that. I'm just showing you what I'm looking for. F is decreasing on this section, so from 0 to 2. If you're going to use interval notation, by the way, you should say like on the interval, negative 1 to 1 or 0 to 2. And then for part D, on the axes provided, sketch the graph on the closed interval negative 2 to 2. So we don't often have to sketch the graph, but sometimes it happens. This was 2002. So yeah, you would be given a graph. We're just going to have to make our own here. So we're going from negative 2 to 2. And this is the graph of G. All right, so remember, we have 1 point to go off of right now. G of negative 1 is negative 3 over 2. So right here is g of negative 1. Okay, and then I can find some other values. I can't just like roughly sketch this. I need to figure out what's g of negative 2, what's g of 0, what's, et cetera, et cetera. So let's do a little chart here. So g of negative 2 will be the integral from 0 to negative 2 of f of t dt, which is going to be the negative integral from negative 2 to 0, which is going to be negative what? Let's look back here. So here's, now see, this area is symmetric, right? This is a negative 3 over 2, and this is positive 3 over 2. So from negative 2 to 0, that, the negative does not matter. That's just 0. So -2, I could plot a point at 0. And then what's g of 0? That's the integral from 0 to 0 of f of t dt. That's easy. That's 0. Okay. What's g of 1? G of 1 is the integral from 0 to 1. That's this positive area right here. It's the integral from 0 to 1 of f of t dt. So that's equal to positive 3 over 2. So at 1, I can plot 1.5. And I bet g of 2 is 0. Let's look. Yeah, from 0 to 2, another symmetric little area. These are the same areas, but this one's negative, this one's positive. So their net area is 0. Excuse me. Now, what about concavity? So remember, concavity, G double prime is really F prime. So anywhere F prime is negative, G should be concave down. So we said G prime was negative on 0 to 2, so concave down when you connect these sections. And F prime is positive here. The graph is increasing, so concave up on this section. All right, so there's G. Don't put arrows on the ends because we don't have any arrows on the ends here either. All right, that's it for that graph.